Hello, this is how to install and use the JEB decompiler on Windows. We are going to create a Microsoft Visual C++ executable, and then we're going to decompile to C programming language using the JEB decompiler. And we're also going to see if the decompiler can figure out the C++ classes. So let's install the software. pnfsoftware.com is the website. We have the option of JEB Community Edition, and then there are demos for Pro JEB Android. Let's look at the differences between these products. Products main menu, and then JEB Pro Android C, which is Community Edition, feature matrix. We want Intel x86 64 decompiler AMD 64. We might also need a 32-bit support for Windows. And then we want the Visual C++ class disassembler. So from the homepage, pnfsoftware.com, we go to the final part of the page where it says learn more about the JEB. And then we're at partial class recovery and decompilation to C++ for programs compiled with Microsoft Visual C++ C video. This is what we're after. We want to install the application. We want to decompile as best as possible to assembler to the C programming language, but then we also want to see the limits between C++ classes. Hopefully just the Community Edition is enough for us. So I clicked on the JEB Community Edition button. It says that as a feature, there's what we're after, which is partial class recovery and decompilation to C++. And we want to download, save. It's a zip archive. Let's see how we install it. The download finished installing. It's a zip file from the main menu of the website, resources, software manual. Let's see how to install the application. The application is distributed as a zip archive. Inside there's a UI client, backend components, and it requires the JDK version 17. Let's see these. Let's cut the file and put it in C:\temp\bin. Let's extract and see what's inside. I'm using 7-zip for the extraction. The file manager is named Total Commander. So it's a batch file, jebwincon.bat. The big thing that we're interested in is how we're going to install the Java SDK, the JDK, and how we're going to configure that JDK to launch JEB decompiler. For that, I'm going to probably edit the batch file in here. Okay, so it says that we should prefer a JDK over a JRE, we need the bin directory, and then we need the java.exe directory. JEB does not come with its own Java. For instance, in the bin directory, there's no runtime subdirectory. So we're going to put in here what we need. Okay, let's read further. Says that JEB requires JDK 17, not 18 or above. Let's download this. I have searched for JDK 17. There's two options, either from jdk.java.net or from oracle.com. Let's pick a random of these two. Let's find the newest JDK 17. So we're at oracle.com/java/technologies, downloads. There's Java archive, previous Java releases, Java SE 17. And we're back to the page where we started from, which is this one. But this way we know that this is the newest version of the JDK 17 that's provided by Oracle. We want the 64-bit version for Windows. And we're going to use the zip one, not the executable installer or the MSI installer. So this guy. Download. And I'm not going to sign in. Let's choose the second option. JDK builds from Oracle, jdk.java.net. Says that I should not use this because it's too old. Open JDK archive. 1702. Windows, zip. It has downloaded into the downloads directory. Let's move it out from here towards the bin directory. Let's extract it. And this is the directory that we're after, the java.exe, this guy. So set java as c:\10 bin java.exe. Java exists, then go to run installed. So it ignores the environment variable Java home. Yeah, this should be it. Let's see if it runs. So JEB C, JEB WinCon, double click. Okay, EULA, accept. JEB 5.30 from 3 days ago. So I pressed the generate key button and then continue. Do not display tips at startup. Close. And now we need an executable that's created with Visual C++. So for that we have Visual Studio 2022 Community Edition. We're going to create a project or solution. This is the directory. What is it opening? No, cancel. We want to create a new project. Okay, we want C++. We want a very extremely simple hello world without MFC, ATL, etc. Hopefully this is the one. Console app. Next. Control V, console application 1. Create. Okay, so this is exactly what we wanted, the simplest hello world application possible in the C++ programming language. Let me clean up a bit the Visual Studio. I am removing from the main toolbar that's always visible all of the buttons that I know the shortcut of. Reverse continue. Find in files, find solution explorer, properties, toolbox. Okay. And I only need the standard toolbar. Let's see if everything works. Let's use the debugger. Save. So the debugger works, but it doesn't look the way I like it. Okay. Let's see if the shortcuts are the one I expect. F10, F11, F10. Okay, everything looks okay. Let's hide the toolbox for now. We don't need Git. And we have class view. Okay, let's find the executable. Let's also do these settings. So tools, options, debugging. Automatically close the console when debugging stops. Automatically close the console when debugging stops. Okay. Press enter. Let's find the executable. Console application 1. Probably this one. Let's see if that's the case. I want line wrap here. So this is it. Console application 1, x64 debug console application 1. Let's execute it. Closes automatically. And it does what we want. So this is the executable that we're interested in. Let's see how JEB works. File, open, Control V. Okay. Processing x8664 image. Okay. So let's see what we have in here. Resources. So these are the resources that are part of the executable. We can view them like this, make a copy of the executable, rename as res, double click on it, opens with Visual Studio. There's just one resource inside, RT manifest 1, which is a manifest about UAC, user account control, where it says that it doesn't request UAC elevate as administrator when the executable will start. Okay. So this is the simplest C++ executable, but it's a Windows style executable file, which is the format PE, portable executable. If we look inside, we're going to see that it starts with 4ccmz, and then there's this plain text ASCII 7-bit character string. This program cannot be run in DOS mode, which we can also see in here. Then there's a ton of boilerplate code that's part of the standard way Visual C++ executables start. The actual payload is going to be further down. And then it's using the C++ standard library. Let's see where the hello world is. So we want hello and world. Okay, it's the same 7-bit encoding. It's not Windows style 2 byte per character, so UCS2 UTF-16 little endian. Okay, can we run this thing in the debugger? Debugger target is invalid or does not exist. Bug. I want to edit a bit the source code, but then I cannot build because it says that the executable console application 1 is open for writing, which means that the file is locked, the file is in use, and it's locked by JEB C, so I needed to close the project in JEB CE, main menu, file, and then close. Now I want to open. The installation of Visual Studio is fresh, doesn't have my keyboard shortcuts. I want, similar to Visual C++ 6, F7 to be build the current selection. And for this, I'm going to edit the key bindings. So tools, options, search for keyboard. And I want to find all of the actions and extensions that are bound to the F7 key. There's 3 of them, one inside the difference viewer, another one in the settings designer. I don't use the difference viewer, I don't use the settings designer, and there's one which is global. view toggle designer. So let's remove this one. Toggle designer. I want to remove the global F7. And then I want to build selection. I don't know which the action is, but I do know how to find it. So it's from the main menu, build, and then build console application 1, so Control B. So we actually want to replace this Control B with F7. So back where we were, Control B, it's called build selection. Okay, we can see that the shortcut is Control B, remove, and let's assign a shortcut F7 and assign globally. Okay. Visual Studio main menu, build, and then build console application 1 is F7. Okay, we finished building. Let's see if the executable will actually wait for user input from standard input from the cmd.exe terminal. F10, so should wait for input, and then it continues. Let's run without debugger, the same thing. Waits for input. Okay, let's actually write what we want here. A. Great. Okay, now we have a newer executable. We can open it from JEB C main menu, File, Open Recent. Okay. It's processing the image. Let's actually get inside the debugger. But for that, we need to run the executable. So double click on the executable. It's going to wait for us to enter a key. And now using JEB main menu, debugger, start, and then we can attach processes, that's console. Refresh machines list. So it seems that JEB CE only ships with debuggers for GDB LLDB for Windows. I'm not sure even if that works. And then additional versions, other versions of JEB that support Android will be able to use the Android debugger and debug Android binaries. So let's keep this. Let's see how we can find the disassembly for these 3 lines. We have the complete disassembly for the exe file. We can't really find things in here, but we certainly can find things inside the x86-64 image hierarchy. In here, there's interesting symbols. There's a strcut, strcopy underscore s, sprint underscore s, start main2, main2 again. But we don't really know what was the name of the symbol that was generated from this entry point C++ function int main without any parameters. Maybe it was optimized out and inlined somewhere else. Maybe this has a different signature. So we can search for main first. Main CRT startup is probably from one of the Visual C++ libraries. Main2 I can recognize in here getchar, this guy. And then I can recognize hello world, I can recognize press any key. So this thing from rock to np is the disassembly of this thing. And main has been renamed to main2. And the entry point of the executable probably is not main2, but main CRT startup. Routine, trampoline, jump, main2. Okay, so let's see what it does. Check for debugger, just my code. I don't like scrolling left, right, so let's see if we can wrap. From the JEB main menu, edit wrap lines. Doesn't seem to work. In the context menu of the text editor of the main view of the main tool window, x86-64 image disassembly, there's the element go to entry point, which says that jumping to main CRT startup is the actual entry point of the executable. And main CRT startup then goes here and then here, etc. So the standard Visual C++ entry point. There's quite a large number of C and C++ source code lines that are being executed before execution arrives here on line 7 in your source code. There's millions of source code lines that are being executed until execution gets here. And it can stop, for instance, at this breakpoint if you run inside the debugger. Okay, so let's see how it calls this operator less than for cout. So it's MSVCP 140, the debug version, DLL, and in there there's cout, namespace std, basic stream, and then char traits. Char. Standard. Okay, so C++ mangling got demangled. This is the mangled version, the C programming language version of the symbol, not the C++ programming language version of the symbol, with full path. So all of the possible information about the type. including namespace, C++ namespace. Okay, getchar is on ptr ucr tbase.dll. So from a lower level DLL that's being probably used by MSVCP 140.d.dll. Okay, and then the same C++ symbol for writing hello world and a new line. Next up, I want to see what is this symbol, a hello underscore world, and then 2 underscores. I right click on it and go decompile. Says that it's going to create more. So this is an Eclipse shell workbench, which uses Java and SWT. Replace existing views, do not show in future, okay. And it's showing the source tool window in an additional tab. But you could have these, for instance, in side by side. Do we do that? Like this. Okay, so let's see the quality of the decompilation. Check for debugger just my code, which is this part. Back. And then calls this sub, which is the operator, less than. Press any key, hello world, and just plain getchar. And returns a 0. Indeed, it returns 0 because it returns type int, and we did not specify what to return, so it will return success, which is exit status 0 for the console application 1.exe process. I double clicked on the sub, which is this operator, less than. Let's see what's there. Whoa. I want line wrap in Visual Studio. Text editor, word wrap. Okay, let's see what's in here. So it's operator less than the way we would imagine, which is extremely complicated because it's part of the STD C++ standard library. And both the signatures and implementations in the C++ standard library are extremely clever, extremely impossible to read because it needs to respect the contract of the C++ standard library, which is as much performance as possible and as little overhead as possible. So it's actually abusing the C++ programming language to get to the contract of the C++ standard library. Okay, so decompiling the C++ standard library is certainly not a thing that you would want to do when you start decompiling Microsoft Visual C++ generated binary files, so PE files, portable executable files, whether they are DLLs or exe files. Let me edit the C++ source code and stop using the C++ standard library, start using classes, and let's look at the quality of the decompilation. So let's replace this thing with a printf. Press any key, correct. Let's run. It says that it cannot build because the file is in use, which is a really big problem. If you want to have a very short loop between editing the Visual C++ source code, building with Visual C++, and then refreshing it inside the JEB, that's going to take a ton of clicks and time. So you need to remember to, close with saving, maybe. Build F7. Not that easy, the file is still in use. Yeah, it's in use because I wanted to attach using the JEB debugger. So no need for get char any longer. Control S, F7, builds correctly. Open recent project, how we do that. There's a project already. Do you want to open the project? Yes. The workspace will be split in two. Okay. Let's go where we want, which is right click and search inside the image hierarchy for main. Press enter and then main2. Okay, so something is extremely wrong because we don't have any press any key string. Let's see if the executable was built in the same place. Yes, it is. I'm not sure why it did not refresh. JEB did not refresh, does not use the new executable. How do we refresh? I don't know, maybe let's close the project, don't save, and then reopen the file. And do not use the existing project. So no. Would you like to open the existing project? No. Okay. It's processing the image again. Okay, search for main, press enter. And I cannot find our function any longer. So in this search box, I searched for the string hello world. It finds it as a string in here. It has this identifier. And then I'm searching for this identifier, Control F, Control V, finds it in two places, at a LEA and inside an R data. And here it is. We do check for debugger just my code, which is somewhere inside here. There's a proc and an NP. There's the string being used. And then there's the printf. So actually this main was inlined from what I see. Okay, let's go to decompilation. And it's this sentry-based thing from basic OStream. Check for debugger just my code, and then this is actually print. Back to where we were. With parameters hello world and no other parameters. Let's build with the build configuration release, which will remove some of the debug aids that Visual Studio puts around call stacks and arrays, padding, sentinels, and all of those things. And now it actually could build. Okay. Or do we refresh everything? Yeah, it could build because it doesn't build into the same path. It builds into the subdirectory x64 release, not x64 debug. Okay, file close. No, file open, Control V. Okay. And let's search for main. There's the same main CRT startup. And there's this time a function main with the correct name, just main, not main2. There's our string, and then it just does a call to printf, doesn't do all of those debug support around calling sub functions and std call, all of those support for determining that you're not passing the wrong things into a VA args. So in here, it's just a plain printf function from the C programming language standard library. right-click, decompile. And this time, because it's the C programming language, most of the content not C++, the decompiled C programming language resembles more our source code. Let's also add some C++ classes. If I know the syntax. Allocate it on the stack. I have created the simplest possible C++ application that has some classes. There's a program class that just holds the body of the main function. And then there's the simplest logger possible. On log level debug, logs the C++ source code file name and the C++ source code line number, and then the text that's passed. Of course, this thing will get pretty fast wrapped inside a C programming language macro in order not to write this thing, duplicate these many number of characters each time you want to debug, to write a logger line of level debug. Okay, so the thing builds, the thing runs. So it writes the full path to the source code file, colon, and then the source code line number, comma, space, and then the text that we provide to be logged. Let's open this thing in JEB. File, open recent, the one that's release. Okay. And we have main visible immediately. And now we want to try to convert this AMD64 assembler, not just in the C programming language, but also to try to figure out where the C++ classes start and end, even if we don't know exactly the name of the symbol, so the name of the class or the name of the method. So I have investigated inside the documentation of JEB how we can see the classes. So how JEB tries to find if your C++ source code, the original C++ source code, actually used classes. And it does that analysis by default. So JEB, if it finds classes in your source code, will present them as such inside the hierarchy tool window. For instance, in here it presents program, class, the main method, and when it decompiles the assembler, it also says package program and then program : main. That's correct. The only thing that was not that great was that we're using the Visual Studio build configuration release, and this does all sorts of optimizations. For such a simple source code, the method, the class logger did not exist at all. The method debug was actually inlined at the two call sites. And then the same thing happened for the class program. The class did not exist, main did not exist. All of this was inlined in here. So the C++ compiler for Microsoft Visual C++, did undo all of the changes that I did to the source code and simplified everything to just a main function and then 3 lines of code in there. A printf, another printf, and another printf. That's it. So in order to actually have classes inside the generated portable executable, you need to work a ton around all of the optimizations that Visual C++ compiler does. So you can either go properties on the project, C++ optimization, and then change everything in here. So optimization disabled, it was the default value is maximum optimization favor speed /02. Enable intrinsic functions, inline, probably disabled, size or speed, omit frame pointers, and also whole program optimization. And even configured like this, it will still do some changes to your source code before actually generating native PE portable executable file. Okay, the same thing, the rebuild does not work. JEB close, no. Rebuild. JEB file, open recent, the one with release. Do not show this dialog in the future. Okay. And now we have what we want inside the hierarchy tool window. We have the logger class, which is shown as a package in here. And then the program class, which is also shown as a package. Okay, we have go to disassembler, so to the body of the method shown as AMD64 assembler. We have right-click decompile. It calls this debug thing. I'm not sure why it doesn't say logger : debug and then this PTR. Okay. Inside the debug, there's what we would expect, which is printf, the correct printf string, because this is probably a string literal. Let's search for it. Yes, it is. It's this identifier a underscore s 2 underscores d 3 underscores s underscore. There's no guessing involved when the C decompiler inside JEB creates this string. Okay, then it has guessed the correct function, which is printf. Did not guess the parameter names, which we can rename ourselves. This one was line number. Okay, and param2 was text. Rename n. The invocation of printf is really strange. So it puts in registry some values and then calls printf. That's what it really happens in assembler. But then when it generates C source code, it should say printf and then put all of the correct variable arguments, all of file name, line number, and text in here. So the generated C source code is not great. I'm not even sure if it's correct. Okay, and let's see if the PTR is actually this. How can we do that? It's not this, it's this logger. Nope, it's the file name. No, it should be this. What is this? G13. Okay, so previously JEB had this feature to try to reconstruct the C++ classes, which only works on Windows and only works for Microsoft Visual C++. As an experimental feature, you needed to actually enable it, but now this feature is ready. It's enabled by default. Just make sure that your source code does contain whatever. When it gets built and optimized by the Visual C++ compiler, not all of your classes get inlined. Let's build the debug version, debug build configuration, file close, no, file open recent debug, no. There's all of the extra sentinels and debug helpers. But this is better than what the previous call. So when it decompiled the version of the product built using build configuration release, it just said printf and then the format string in here. Right now, the printf is wrapped inside the Visual C++ debugger machinery, but then we can actually see how parameter 0, 1, and 2 get used by the printf. Not really, because parameter 0 is not used. So this is the actual string. Parameter 1 is the line number, so this part, and param 0 is nowhere to be found. Yeah, so this C source code is wrong. Then for main, debug once, twice. This string is hard-coded, it's a string literal. I'm not sure why it's not showing it. It's showing this G13. Yeah, it's what it is. Some things work, some things don't work. But when decompiling a executable that was compiled from C++ source code, there's a ton of manual labor that is required and a ton of manual human understanding involved. Sometimes you cannot even be sure that the AMD64 assembler is correct. But if there's 0 bugs in here, then you can improve the generated C++ and C source code. So you're using decompile from JEB. It will do some things, it will do some work for you, but then the work is incomplete. There's all sorts of bugs in here. So it's up to you if you trust the AMD64 assembler to improve the generated C++ source code or C source code yourself by hand. So this is just a helper, a start, a scaffold, but there's a ton of manual intervention that needs to be done in order to generate the correct C or C++ source code. So this is it. This is how you install the latest version of the C and C++ decompiler named JEB Community Edition version on Windows. In this case, it's the operating system Windows 11 Pro. We have generated some executables using C source code and C++ source code using Visual Studio 2022 Community Edition. We've used both the Visual Studio configurations, debug, and release. We worked with the various optimizations that exist for the build configuration release. We saw how that affects the generated assembler. So the debug build configuration adds a ton of debug helpers, a ton of sentinels and validation, and VA args validation, etc. And all of that will be then visible inside the AMD64 assembler and also available in the C and C++ source code that's generated by JEB when you go right click and decompile. And also JEB will strive as best as possible to detect the C++ classes and the C++ methods, which is very helpful. Instead of just having the raw AMD64 assembler, you also get helpful comments and also C and C++ source code and also C++ class structure. this is it. Thank you.